In the new C++ Builder exe3 64-bit compiler, you can use inline assembler, and I was asked by Peter back in December how to get it to work, and I wrote a blog post about how to use the 64-bit inline assembler. Since we're based on the Clang compiler, and the Clang compiler uses the same AT&T inline assembler syntax that the GCC compiler uses, I searched on the internet and found some articles. One of them about Clang inline assembler compatibility. It talks about GCC. I found some really good articles. Here's one that talks about the syntax, output operands, input operands, and list of clobbered registers. Then also an article with an example on Intel's website. And these links are all off of my blog post. But I just wanted to show the support in the IDE for doing inline assembler in 64-bit. Two examples. First example is the one from the Intel site. I just define a structure of two 64-bit numbers to give me the high and low of a 128-bit value. And then I have a macro defined with some assembler code, underbar, underbar, azum, underbar, underbar, that will do a addition of two 128-bit numbers. So here's the template, which is going to do an add of these two parameters that are passed in, and we're going to use the equal R, which says use a register for the low and high part, and then the two inputs are coming in as parameters. I'll define the values and the result as this structure, my I128. We'll set the high and low values, -0 for low and 0 in the high, and then 65 and 1 for the high and low. And then we'll call add 128 and produce the result. Let's look at this in action. There's the console window. 64 bits is the value 65, and lower is 1. And here's the -0 and 0 for the first value. So we add those two together, and we get the carryover to give us this very large number, 42. Another example to add to 64-bit integers using azum. So here again we have two values, x and y, and a return value, all being 64-bit. And we'll define the azum for this add 64 function, and it will just add the two numbers together and return the result. And then we'll use printf to output the values for the additions of two different values that would work on 64-bit and handle overflow properly. So here we add two 64-bit values, and in 32-bit world that works. If we take a large number, that's the max in x64, and add, it would overflow. But of course in 64-bit, it all works, and it does the right addition for the larger 64-bit number. So I'm not here to teach you how to use the assembler itself, but just show how you can use inline assembler in your applications. And while we're in this code that has all these printfs, one of the other side benefits of building this 64-bit C++ builder compiler on Clang is that Clang also does validation of format specifiers for printf. So let's go and compile this, and we get this warning. It says format specifies type double, but the argument has type integer. Program still runs, but it doesn't output the right value for the second printf. There's lots more new capabilities in the 64-bit compiler. We won't be able to get to all of them in this video or other videos. Of course, C++11 is stricter and safer. You can use binary constants, intrinsics, and built-in template handling, more descriptive error and warning messages. All that is included in the 64-bit compiler. And of course, you get all the C++11 language and library capabilities that are implemented in this release of the compiler. So lots of great stuff using the 64-bit compiler, and more to come.